All right, welcome to the second part of 1.4. We're going to be going over the intermediate value theorem and applications of it. All right, so intermediate value theorem does relate to continuity and limits, more so continuity between two given x values. So if f is continuous on a closed interval a to b, and k is any number between f of a and f of b, then there is at least one number c between the endpoints of the interval such that f of c equals k. So if we can confirm that something is continuous on a closed interval and confirm that this k value is between the y values of that interval, then we should be able to confirm that there is a c in there such that f of c equals k. So that y value is between those two y values of the endpoints as well. So two things to remember before we can use this conclusion, this then statement at the end, we have to state that our function is continuous and evaluate those endpoints to show that k is in between f of a and f of b. All right, so let's take a look at an example for this one. It's a little easier to see it in practice than to see it theoretically there. So what we're going to do is use the intermediate value theorem. We use IVT to shorten it to show that this function, x cubed plus 2x minus 1, has a 0 on the closed interval 0 to 1. First, what we need to do in order to do that is we need to decide if this is continuous. Nice thing about this type of function, it's a polynomial. All polynomial functions are continuous on the whole real number line. So from 0 to 1, this is going to be continuous. So that's the nice thing about that. All right, so yes, f of x is continuous on 0 to 1. All right, next we need to figure out what this proposed k value is, and we need to confirm that it's between f of a and f of b. So they're saying, say we're trying to confirm that this has a 0, so k is going to equal 0. And the next question is, does that fall in between f of 0 and f of 1? Because 0 and 1 are our endpoints. So f of 0 is negative 1. 0 plus 0 minus 1 is negative 1. And f of 1 is 1 plus 2 minus 1, which is 2. So now you need to ask yourself, okay, f of 0 is negative 1. Is that less than 0? And is that less than f of 1? Well, yes, 0 is between negative 1 and 2, so check. So we've showed it's continuous, and we've shown that 0, our proposed k value, is between f of 0 and f of 1. So then we need to do the conclusion. So this is going to have three parts. First part, f of x is continuous on 0, 1 because it's a polynomial. All right, next, we need to say that our value of k equals 0 is between f of 0 and f of 1. 0 is between f of 0 and f of 1. And then lastly, our conclusion is basically stating this then statement and filling in the values that we know. All right, so then we can say therefore, there is, and we're going to just copy it down, at least one number c on the interval 0 to 1 so that f of c equals 0. Okay? And we could go and find that if we wanted to. We would just have to take our f of x equals x cubed plus 2x minus 1, make it f of c, and then set that equal to our k value of 0, and then solve for x. We won't do that just right now. All right, so why don't you see if you can give it a try? So see if you can follow, answer these 3 questions first, and then write the conclusion for this example. So pause here and give that a try. All right, so you can see in red here, first we confirmed that f of x is continuous because it is a polynomial. And f of 1 is equal to -2, f of 2 is equal to 1, so therefore f of 1, or 0, the proposed k value, is between f of 1 and f of 2. Therefore, there is at least one number c on 1 to 2, so that f of c equals 0. Now, like I mentioned up here, we can actually find c. So all you have to do is take your function f of x, make it f of c. So f of c equals c squared minus 3. I just plugged c in for x. C squared equals 3. C equals plus or minus root 3. Now we're looking on the interval 1 to 2, so the only possibility for c would be positive square root of 3. So then in orange here, that's how you would just take it a step further to find that c value. Now, the common question with the intermediate value theorem is like, okay, that's nice, we can use it with polynomials, but how might we actually apply it? Here is an application problem, and it is one like you might see on an AP test. What they like to do, this is an example of a no calculator question, so we're going to try and get through this, and I'm going to show you strategies that you can use so you don't have to use your calculator. So this function right here, it's a piecewise function. We've been looking at piecewise functions with continuity and all of that. This represents the total accumulated revenue a company has received in T years since 1980. Now, this company also has accumulated expenses, and that is modeled by this function E of T. And that's measured in millions of US dollars and T years since 1980. So according to these two models, we're trying to see, is there a time t from 0 to 5 at which the total accumulated profit, which would be now what we're trying to look at here is actually R of t minus E of t, is equal to 0. So we're just looking from 0 to 5. So we are only looking at this half of our function because that's where 0 to 5 lands, is with this 41 square root t over 20. So R of t that we're going to look at is going to be 41 square root t over 20. And then we're looking at E of t, which is 3 log base 2 of 12t plus 4. Now, these might look kind of scary because you're like, wait, there's radicals and there's logarithms and it's a no calculator. Scary. It's really not so bad. We're going to use some of our properties that we learned in pre-calc. That's why we're reviewing a problem like this. So is there a time t in an interval? That's kind of your hint that we're using the intermediate value theorem, right? We're looking for a specific value. We're trying to show that there's a value between 0 and 5 so that our total accumulated profit is equal to 0, which is our k. All right. So let's look at our first step here. First, we have to show that our function R of t minus E of t is continuous. So first step is R of t minus E of t continuous on the interval 0 to 5. That's our first question, so let's look at it. And this is one of those two you're going to want to show every step you do. So you're going to show this first step. Is it continuous on 0 to 5? Well, is 0 to 5 in the domain of 41 root t 41 root t over 20. Well, for 0 to 20, so yes, r of t is continuous. And then e of t. Now this one we have to do a little more work. 12t plus 4, okay. 12t, now 3 log 2, 12t plus 4. Remember, in order to be continuous, logarithms have to be 0 or have to be greater than 0 inside the logarithm. So for e of t, we need to check when 12t plus 4 is greater than 0. So we solve for that. 12t is greater than negative 4, so t has to be greater than negative 1/3 in order for this to be continuous. Well, 0 to 5, those values are all greater than negative 1/3. So check, e of t is going to be continuous. So r of t minus e of t is continuous on 0 to 5. All right, first question answered. Second is k equal to 0 over here? So is k equal to 0 between r of 0 minus e of 0 and r of 5 minus e of 5? Okay, so now we have to do some math. So now we have to find r of 0 minus e of 0. So r of 0 is going to be 41 root 0 over 20 minus 3 log base 2 of 4, right? 12 times 0 is 0 plus 4, okay? Well, 41 root, this ends up being root 0, so 41 times 0 is 0, minus 3 log base 2 of 4. Remember, that means 2 to what power equals 4? So that's 6. Log base 2 of 4 equals 6. So this is equal to negative 6. R of 5 minus e of 5. So r of 5 is going to be 41 root 5 over 20 minus e of 5, which is 3 log base 2 of, I think that ends up being 64. So this is 41 root 1/4 minus 3 log base 2 of 64 is 2 to what power equals 64? So that's going to be 6. 2 to the 6th is 64. So this is 41 times 1/2. The square root of 1/4 is 1/2. So this is 41 halves minus 18. And I believe 41 halves minus 18 is 2.5. All right, so is 0 between negative 6 and 2.5? Yes. So r of 0 minus e of 0 is less than 0 because it's negative 6. And then 0 is less than r of 5 minus e of 5. All right, so we've got that. Our k value is in between those. We found that the function is continuous on 0 to 5. Next is to finally write our conclusion. So once we've showed those two things, we can then write part 3. Therefore, there is at least, and this time we're talking about t, not c, there is at least one time t on 0 to 5 where r of t minus e of t, okay, so their total accumulated profit is 0. Or if your total accumulated profit is 0, you've broken even. So those three parts together make up your answer. And since this is a free response question, all of your work that you show is also part of that answer. All right. So make sure as you're writing this down, you're showing all of your work. When you come across this type of problem on your intermediate value theorem LT check, make sure you keep this handy.